We've seen this in this class before. We just didn't recognize it. On the second day of class, I showed you this little truck. And you remember, on the second day of class, that was just magic. And that was just my way of saying, this class is going to be magic. But what's happening here is that this little smokestack is actually blowing air. And so this little styrofoam ball sees a region right above the stack that has a velocity. A velocity means a low pressure. The rest of the air in the room is not moving. So that's a high pressure. So anytime this ball wants to get out of the stream, it's going from a low pressure region to a high pressure region. Now I can do that on a bigger scale. Danger, danger, Will Robinson. Let's see if I can spin it. Do it. Oh. Come on! You're not getting supper. I just broke it. This is going to come out of my paycheck. Okay. Now, if you think about an airplane wing and think of the forces on that wing, okay, so here's an airplane wing. Actually, that wouldn't be a very good airplane wing, would it? No, an airplane wing, you want to have an airfoil like that. And if I think of that airfoil slicing through the air, let's look at two chunks of air. Well, this chunk of air, as the wing goes past it, it will end up here. And this chunk of air will end up here. And so relative to the wing, this chunk of air has a small speed, and this one has a big speed because it's traveled a further distance in the same amount of time. That means I would have a low pressure here and a big pressure there, giving a net push up that keeps the airplane afloat. Now, here's another thing that you can do if you don't have an airplane. If you go home and get a spoon and go into your kitchen and get the faucet running so that you've got a stream of water. And then take that spoon and just hold it. Those are your fingers. You got skinny fingers. Hold that spoon near the water, but not touching the water, just close to it. And that spoon will get sucked right in, because that flow of the water is a low pressure area. And so the air around is going to push it in. Now, if I take this blower and don't want to lose that. If I now, what I'm going to do, Barrett didn't agree to this, but He's a good sport. I'm going to cock this, move your hand, be a man about it. What's happening is that the air, in order to escape from around the ball, has to be going very, very fast between this surface and the ball. That makes that region between the surface and the ball a low pressure area, and it actually sucks it in at the same time it's blowing air around it. Now I've got one last demo. If I take this blower and I hook it to this contraption here, where I've got a fat pipe, a skinny pipe, a fat pipe. Think of Stick Spock and Stick Picard. Where's the pressure going to be high? Where is it going to be low? I'm going to blow from those regions air up these stacks, and I'm going to float these ping pong balls. Predict with your neighbor where the ping pong ball is going to ride high and where it's going to ride low. Okay. This is a high pressure region, a low pressure region, another high pressure region. And again, using this principle, Bernoulli's equation, let's see if I can land them. Okay, folks, have a good weekend.